फ्रेंड्स, आज हम फिर से आ चुके हैं उसी चैप्टर का पार्ट 2 पे, जो कि साइंस चैप्टर 7 था। उसका पहला पार्ट पढ़ चुके थे हम। 99 पेज से लेके 105 पेज तक का पढ़ चुके थे। ठीक है, अब आज आ चुके हैं उसका पार्ट 2 को लेके। पर्टिकुलर नेचर ऑफ मैटर का ये है। चलिए इसको शुरू करते हैं नेक्स्ट पेज से, जो कि है 106 नंबर पेज। तो 100 ये आ चुके। चलो यहाँ से शुरू हो रहा है, इसको यहाँ से शुरू हो रहा है। तो चलिए शुरू करते हैं इसको। This illustrates that the particles in gases move freely in all directions, and the interparticular attractions are negligible. As a result, gases do not have a fixed shape or volume. In these activities, smoke is used to represent the gaseous state. The tiny particles of smoke suspended in the air are constantly hit by the invisible particles of gases, and their movement help us observe the motion of gas particles. This activity can also be demonstrated by using iodine vapor instead of smoke from incense stick. Iodine vapor can be obtained by placing some solid iodine in a closed gas jar for some time, as shown in figure 7.8. Both liquid and gas flow and do not retain a fixed shape. These properties distinguish them from solid and classify them as fluids. What role does the interparticle spacing play in determining the properties of each state, solid, liquid, and gas? Let us perform the following activities to find answers to these questions. यहाँ पर एक एक्टिविटी है, तो इसको छोड़ते हैं, यहाँ से शुरू करते हैं। As you do this, you will notice that volume of air inside the syringe decreases. What we can say about the behavior of gas in the syringe? When you compass the air by pushing the plunger, the particles are forced to come closer. This shows that the gas particles have a lot of space between them in their natural state, and this space can be reduced by applying external pressure. If you stop pushing the plunger, and gas particles spread and the plunger moves back to its original position. You repeat this activity using water and observe. You could observe that water is practically incompressible. Let us perform another activity to learn about interparticle spaces in liquids. यहाँ पर फिर से एक्टिविटी, इसको छोड़ते हैं। यहाँ पर भी एक्टिविटी रहेगा, उसको छोड़ना है। इधर पे भी है। चलो यहाँ से शुरू करते फिर से। What differences do you observe in water levels? Do you observe that intricately when sugar is added, the level of water increases, but after dissolution it may increase to some extent since the volume of solution is less than the sum of the volumes of water and sugar? It indicates that there is some space between the water particles. The particles of dissolved substance occupy these spaces. Repeat the activity 7.7 with some other soluble solids such as common salt or glucose, and insoluble solids like sand and stones pieces. What do you observe in each case? Do the sand particles dissolve? Does the volume of water in the vessel change after mixing, and why? Sand is a solid that does not dissolve in water. When added to water, the sand particles settle down and occupy some space in the container, causing the total volume to increase. What do you think about the interparticle spacing in solids? What earlier you learned earlier that the constituent particles in solid are held together by strong forces of attraction, so these particles do not move from one place to another and are closely packed. However, despite close packing, some space is left between the particles as shown in figures 7.12. You might have assumed that the space between particles is filled with air, but this is not the case. They contain nothing at all. Summarize the packing of particles and interparticle spacing in the three states of matter. The principle. This happens because the water particles are in constant motion. First, they pull out the particles of potassium permanganate from its grain, and later they heat these particles so that they can get spread throughout the liquid. In the case of many substances, the constituent particles are held together strongly that the water particles are unable to pull these out. Such substances like sand are insoluble in water. The activity when an incense stick is burned in one corner of the room, indicates the fragrance is felt only around the incense stick. Shortly, you can smell the fragrance throughout the room. This happens because the particles of the fragrance spread, filling this entire room. This shows that the particles of air are moving constantly, and the air particles hit the particles of the fragrance and help them spread throughout the room. You can share few other real life situations where yeah, we experience the movement of gas particles. Based on our earnings from the chapter, we can say that matter is made up of small particles which are held together by force of attraction. The strength of attractive forces between particles depend on the distance between them, which is in turn depends on the thermal heat energy. Thus, it is the thermal energy of the particles that determines the physical state of matter. In the solid state, the, the thermal energy of particles is low, so that remain close to each other and experience strong interparticle attractive forces. They restrict their motion to only small vibration at the melting point. The thermal energy is used to overcome the attractive forces between particles, allowing the solid to change into a liquid. At this stage, the particles can move away from their fixed positions. The interparticle distance increases slightly due reducing the strength of the attractive forces to a level that allows the particles to move around through still within a limited speed. In this gaseous state, the particles have enough energy to overcome the forces of attraction between them and move freely in all directions. You will learn more about these particles that constitute matter in higher grades. Let us warm up practice nature of 3 states of matter। इधर एक क्यूरियोसिटी एलएफ को छोड़ते हैं क्योंकि इसमें सिर्फ क्वेश्चंस है, इसको छोड़ता भी। यहाँ पर है डिस्कवर, डिजाइन एंड डिबेट, इसको पढ़ते हैं। Fix a balloon over the neck of the bottle and pour the bottle in hot water. Explore what will happen. Design and create simple models to represent particles of solid, liquid, and gas, showing in the interparticle spacing using clay balls, braids, etc. pretended to be particles of solid, liquid, and gases at different temperatures. Grade then perform a role-play dance showing particles in motion. Debate in the class. Gas can spread and fill at the available space. Is this property of gas beneficial or harmful? सो स्टूडेंट्स यहाँ पर हमारा चैप्टर ख़त्म होता है। तो ये अभी जल्दी से जल्दी नेक्स्ट वीडियो में मिलते हैं। तो इस चैनल को सब्सक्राइब कीजिए, मेरा चैनल को सब्सक्राइब कीजिए और इस वीडियो को लाइक कीजिएगा अगर अच्छा हुआ है वीडियो को। और अगर कहीं पर प्रॉब्लम है तो प्लीज़ कमेंट में लिखिएगा कि कहाँ पर प्रॉब्लम है रीडिंग में। और मेरा एक और न्यू यूट्यूब चैनल है जो कि म्यूज़िक बीट स्टूडियो, सोरांशु साधु म्यूज़िक बीट स्टूडियो, वहाँ पर भी जाके वीडियो देख लेना। जो बीट्स है वो कैसा है वो भी वहाँ पर कमेंट में बताना। अच्छा लगा तो लाइक कीजिए इस वीडियो को, और वो बाकी सारा वीडियो भी अगर अच्छा लगता है तो लाइक कीजिएगा प्लीज़। मिलते जल्दी नेक्स्ट वीडियो में। बाय स्टूडेंट्स।